Hello students. Welcome to the YouTube channel, Physics Simplified. In this video, we will discuss one of the special cases of the projectile motion up an inclined plane. So, without any further delay, let's jump into the discussion. For a projectile fired from the foot of an inclined plane, we will find the condition for which the projectile strikes the inclined plane normally while going up the incline. Like our last video, in which we discussed various quantities related to the projectile motion up an inclined plane, again we have a plane inclined at an angle beta with the horizontal. In case you have missed that video, I will leave the link to the video in the description. A projectile is projected from the foot of the inclined plane, that is, from point O, with velocity vector u, at an angle alpha with the horizontal, up the plane. The projectile strikes the plane at point B. We know that time taken by the projectile to go from point O to point B, up the incline, is its time of flight. As per our previous discussion, it is given by t equal to 2u sine alpha minus beta divided by g cos beta. Again, considering the point O as the origin, we consider the positive x-axis parallel to the plane and up the incline, while the positive y-axis is considered perpendicular to the inclined plane in the upward direction. Resolving the initial velocity vector of the projectile in two rectangular components, the component of the initial velocity up the incline, that is, along the positive x-axis, is equal to u cos alpha minus beta, where alpha minus beta is the angle made by the initial velocity vector with the inclined plane. Acceleration due to gravity is vertically downwards. So, the component of acceleration down the incline is minus g sine beta, as it is directed towards the negative x-axis. According to the diagram, the projectile is striking the inclined plane at point B perpendicularly. So, the final velocity of the projectile at point B along the positive x-axis, that is, along OB, is 0 and is denoted as v suffix x equal to 0. Let us consider the situation at point B. The black arrow is representing the direction of positive x-axis, while the dark orange arrow is representing that of the velocity of the projectile at B, with which it is striking the plane. To simplify the whole situation, we rotate this diagram such that the x-axis becomes horizontal, and the velocity of the projectile at point B, perpendicular to the x-axis, is in the vertically downward direction. We know that if a vector is perpendicular to a line, its component along that line is 0. That is why the component of the velocity of the projectile at point B along the positive x-axis is 0. To find the condition for which the projectile strikes the inclined plane normally while going up the incline, we shall consider the motion of the projectile along OB, that is, along the positive x-axis. From this analysis, we will find that particular angle with the horizontal at which the projectile must be fired up the incline to satisfy this condition. The data available to us for the motion along the positive x-axis are as follows. Initial velocity along x-axis, u suffix x, is equal to u cos alpha minus beta. Acceleration along x-axis, a suffix x, is equal to minus g sine beta. Final velocity along x-axis, v suffix x, is equal to 0, and time is equal to time of flight, that is, 2u sine alpha minus beta, divided by g cos beta. Considering the first kinematic equation along the x-axis, we write v suffix x is equal to u suffix x plus a suffix x times t. Substituting the given data and rearranging, we get cos alpha minus beta is equal to sine beta divided by cos beta times 2 sine alpha minus beta. Further simplifying, we get 2 tan alpha minus beta is equal to cot beta. To simplify the left-hand side of the equation, we will use the following trigonometric identity. Tan A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. Rewriting the left-hand side of the previous equation and rearranging, we get 2 tan alpha minus 2 tan beta is equal to cot beta plus tan alpha tan beta times cot beta. Or tan alpha is equal to 2 tan beta plus cot beta. Therefore, alpha is equal to tan inverse of 2 tan beta plus cot beta. So, if a projectile is fired up the incline from the bottom of the plane at this angle with the horizontal, it will strike the inclined plane at the given point normally.